So this is a continuation of my previous video on how to do the state machine. And in the previous video, the software that we see here was established. So if we look at the cooking hood, for example, we can define a cooking hood, which looks like a lot like the example we did in class. And there's a small simple main method that runs it. You can try running it here. Run as Java application. It prints some stuff and works. Now, this is a little different from the way the state machine was implemented previously. And for a quick catch up for those who haven't seen the video on how this state machine was implemented, I used the visitor design pattern. So the state machine executor here, for example, processing an event, calls current state.accept, and then this is the visitor design pattern. So if we look here, we have state, which has an accept method, and then it does a transition accept for each of them. Here we must assume, since I visit all of the transitions, that only a single transition is ever applicable in a given situation. So if we get the same event, just a second, actually, it's funny. Let me just pause for a second. I think. So sorry, I managed to confuse myself for a second. So what confused me is that when we the accept method here will go through every transition. So you might think it will run every transition, but let's go look at it. Open the implementation here. So when we accept a visitor, we do a visit on the visit for the transition and then execute the operations. And if we look here, we want the implementation, state machine executor. Now the state machine executor cleverly keeps track of whether we picked a transition or not. And if we picked a transition, we don't run it more than once. So we only, for every state, we at most run one transition. So it's a little, somehow it's a little clunky because we both have a loop that goes through all transitions, and then we have something that makes sure we only ever pick one of them. But and I think that's sort of a downside of using the visitor design pattern. So what we have here is a use of the visitor design pattern. Not the most exciting use of the visitor design pattern, but it's there. We have a notion of extended state. In our meta model, we have the whole set of variables. When we use our executor here, our executor maintains the actual state, like the state of each variable, and the current state, so it has the complete state of the state machine. Events are modeled as string, so based on the questions I got, what we're missing right now is actually parameterized events rather than just simple, stupid, basic string events. So let's look at that. In this video, I will take this state machine here and make it something that uses a parameterized event model. So what can we use that for? Well, let's go look here. So basically, we can imagine that every event has an additional, so here events are just strings, but let's imagine that, so basically we want to say that events, in addition to a code like this, a parameterized event might also carry an integer. Now, it's not perhaps so obvious how to do it here, or what to use it for in the cooking hood, but in the microwave, we could have an extended microwave example where we have a power level as well, or an effect. So let's integer state effect like this. And then if we're in the inactive state and we just start cooking, then there's probably some default effect that we use. So we set state effect, comma 900. But we could also imagine that there would be, when we're in the inactive state, we could have a transition, and then there would be set effect. And this then, so now we have to think about how to express this. So what I want to say is that we set the effect, for example, of to some which is, and the point is that the effect is going to be some number that's a parameter to the event. So it's a parameterized event. And then we want to set state of effect to, we're just playing with the syntax here, this X. Now, of course, this isn't really legal code yet, and we also have to think about what we want to do here. Now, the way this is often done in state machines is that you might have an event that's parameterized by a single integer. So if there's only ever a single integer, maybe we don't actually need to give it a name. Okay, so I'm just going to go with this. So let's have it like this. Set effect with a star, and it means there must be a parameter to the set effect command here. And right now we're going to be able to set the state from event. We could also imagine having a condition on the whatever we got from the event. And we could actually do that. Let's do that as well. Let me just see here that when event, so how do we call it here? Just a second. This is the disadvantage of digging up my old code, of course. Let's see what do we have here. When state equals and change state. Okay. When state, when event greater than 0. So we need a positive effect, or let's say it must be at least 100. Then we set the state effect to whatever parameter we got from this. So what this means is that if we look at it here, we start, then that's going to be at an effect of 900 presumably, and stop. That goes back to inactive, and then we can that process event, and then we do a set effect star, and here we want to be able to provide a parameter. So we might give it 50, or let's give it 500, and then give it 50. Then it should 50. It should ignore that. 500 should be fine, and then I start and stop again. So this is what we want. So we start it, stop it, set effect to 500. So the effect is now 500. Set effect to 50, which we should ignore, start and stop. So let's go and modify the builder to have this. Fluent machine. Int compare or value. Okay. And let's go again. So then we can set state from event, and we can create this one as well. String variable name. Okay. Now we have some new things going on in our state machine. So event creator here, we want to return this, and we want current operations dot add new extended state operation kind dot, this is event creator, so we need to create this, and with the value. Like so. So this is a greater than operation. And here we have current operations dot add new extended state operation kind dot event set with variable name and just a 0 because we have to write something, but we don't care what it is. Okay, now we create this enum constant here, so we get new kinds of operations. Okay. And now we want to be able to on a new kind of method here. We create a method process event. So let's put it next to the other one here. Now events, what I've done is that, as I said, there's a star at the end, then there's a parameter. So we want to check in this case that there's no star, because then that should be a parameter. So if event dot ends, this looks good, ends with star, throw new error, illegal. So this is missing parameter to events. Okay. And similarly, let's just grab the whole thing here. And we have an int parameter. So if it doesn't, oh wait, so if it ends with a star when there wasn't one, then we complain, and in this case, if there isn't one, then we're missing a parameter. Okay, now what to do with the parameter? Well, right now our events are strings, and we want to change this. So, and here we have the current event. Let's make that be an event object. And let's create the class events. And in the execution class, that sounds good. Now an event here has a private string code and a private int argument. So public event string C int A, and then we have code equals C, a argument equals A, and we have public string get code, return code. Actually, I think here it makes sense to strip the star away. So let's see. If C dot ends with star, sorry, something went wrong here. It's being stupid. Okay. Dot substring 0, comma C dot length -1. Else code equals C. Okay, so we only take the argument if actually it ended with a C. Get code does return code, public int get argument does return argument. Let's just have this be an integer. If argument is null, which means we never got one, throw new error, no argument to event. Oh, sorry for the mess here. Okay, and like so. And let's put a bit of indentation here as well. Okay, so now we have an event class. Events are constructed with a string and an argument. We could actually have two constructors. That might be nicer. Let's see. Okay, so now we want a current event equals new event, event comma 0, and we're going to ignore the 0 anyway. New event, event parameter. Okay. Now, somewhat surprisingly, there are no errors here, but this is probably because of the way I use the current event here. So let's just see. Yeah, this is bad. So if here we check that just the code itself, and for it's applicable, we need to pass in the event as well. But let's do that afterwards. Are any other uses of current events? Nope. That's it. Oh, we might need a toString on the event. Public string toString. Return plus code plus, and then argument is different from null. Then we put the argument in there. Otherwise, nothing. And then, okay. So we include the code if it's there, hopefully. And now we just need to make sure that we pass in the event here as well. That was, sorry, current event. Okay. Change method. Event current. Oh, that was in the same. Sorry. We don't need to pass it as an argument. Just need to remember to use it. So is applicable. Checks if a given transition is applicable. If it's an equals. Else if dot get kind equal kind dot event greater. Then we want to say int event value equals current event dot get argument. Okay. And then we want to say that the string is an integer variable value. Oh, sorry. Then we going to say int compare value. This is, we get that from the operation. This is the value that it had. And then we want to say return whether the event value is greater than the compare value. I think we have to try this to really be sure. Okay. And the other thing we need to do, of course, is to implement the set operations. So we say if up dot get kind equals kind dot event set. Oh, sorry. Then say that what we want to send it to int value equals current event dot get argument. Okay, and then we want to do extended state dot put up dot get variable name comma val. Okay, so now with our parameterized events, we can check if the whatever we had is greater than. We could also check equals and less than, but that's just the one I implemented for now. And we also have a change event. No, I said where we set the some internal state variable to whatever parameter we included. So let's try this. I have no idea if this works. Run as Java application. Okay. So partial success, it didn't crash. And we have a set Hmm. So we have on start, we go to cooking. This is slightly funny. So here, this is, I use the print visitor to print it, which can be useful. And here I just have I'm not getting the second transition here. Maybe I'm missing. So I think there's a problem in my builder here. So when do I call flush transition? Just going to pause this for a second while I think. Okay, I think I have it. What the problem was. So if I look at my cooking hood, then I always have a 2 here. So I have a transition plus 2 power on, even if it's power on. So it's not quite the same as the one I used in class. So I think I might need to say 2 inactive here, like so. I haven't actually tried this. So although note I did add a defrost. So defrost here. Okay, now we have events, set effects, goes back to inactive, and it has greater than 100 and set effects. So let's see. Okay, now it runs. We get inactive, start, stop, set effect 900, and effect is 900 no matter what we do. So it runs, but it doesn't really work. Events with parameters are correctly put here, so it's something else that doesn't work. I'm just going to pause while I think again. So I now realize that cleverly stripping away the star was maybe a bad idea. So here it expects an event called setEffectStart. That's what it says in the transition object. But in my events, I cleverly removed this. So I think I'm just going to not remove it. And let's not avoid being completely stupid here. So we always take the code, whatever it is. And if it ends with a star, then we take the argument as well. Well, let's try this. Success. Okay, now of course, my program doesn't quite work. So here, see here what's happening. So we have effect 0, effect 900, and we set effect to 500. Good. It says effect to 50, doesn't work. That's also good. Then we say start, and then of course effect becomes 900 because that's what our program says to do. So if we are to fix this, then then we could say that when state equals, so when the effect is 0, set it to 900, start, if otherwise, takes us to uses whatever state it was. Defrost sets the state to 300 and starts cooking, and set effect sets it to something. Okay, if we go to inactive, then we want to say that sets, no, actually, if we do a stop, then we set the state effect to 0. And if we then we set the state effect. So this was an error in my state machine program. Let's try this. With the trace. There's a little bit of my own debugging here, sorry. So when the effect is 0, we press start. That brings us to the cooking state with effect 900. Press stop. Effect was 0. Set to 500. Start cooking 500 and stop, and then we're good. Okay, I think this is good enough. There might be small errors, but I'll stop before I bump into that. Let me just remove this to get a nicer trace. Okay, so that's it. So now we have parameterized events. We have our visitor thing that puts the executor in a single place. Lots of things could be nicer, but I think it works. So I think that's enough. Thank you for watching if you watched this far.